Welcome to Hired in IT. Our mission is simple: help you build the skills that employers actually want. Whether you're trying to land your first IT job, switch careers, earn a promotion, or increase your salary, we're here to help. Every video is thoroughly researched and designed to make complex IT topics easy to understand. If there's an IT topic you'd like us to cover, leave a comment below. We may turn your suggestion into our next video. Turning IT knowledge into career opportunities. A junior developer is staring at her Windows laptop, but the deployment target is Linux. It's Friday evening, the sprint ends Monday, and her IT budget sure doesn't cover a second machine just for testing. So she does something that takes about 10 minutes. She spins up an entire new computer right inside the one she's typing on. That's exactly what we're tackling in this part of the IT Fundamentals Masterclass: virtual machines. By the end of this video, you'll be able to define a virtual machine and its two main types, explain how a hypervisor carves up real hardware into isolated guests, and actually set up your own VM on your computer using completely free tools, step by step. No theory for theory's sake. You'll leave with something you can do this week. Imagine opening a window on your computer, and inside that window is an entirely different computer. It has its own processor, its own memory, its own hard drive, its own operating system. You can install software, browse the web, or even break it completely without affecting your real computer. That's a virtual machine. A virtual machine is simply a software-based computer running inside a physical computer. Your physical computer is called the host. The virtual computer is called the guest. Between them sits a special piece of software called a hypervisor, which decides how much CPU, memory, storage, and networking each virtual machine receives. To every guest operating system, it looks like it's running on its own dedicated hardware. But behind the scenes, multiple virtual machines are safely sharing the same physical computer. That's the magic of virtualization. Before virtual machines, the rule was one application, one physical server. That meant companies ran dozens of machines, each idling at 5 to 15% utilization, burning electricity and rack space, and still demanding cooling and maintenance. A mid-sized business I saw once had 40 physical servers for 40 small apps. After consolidating most of them onto 5 hosts running virtual machines, they cut about $200,000 a year in hardware, power, and cooling, and freed up half a data center room. That's the entire reason virtualization took over. Turn wasted metal into software you can duplicate, move, and reclaim. Imagine you're an IT administrator 20 years ago. The accounting department needs a new application. Your first question isn't, what operating system should we install? It's, where are we going to put another server? Every new application means buying more hardware, more rack space, more electricity, more cooling, more maintenance. Now imagine virtualization arrives. Instead of ordering another physical server, you click New Virtual Machine. 10 minutes later, the new server is ready. That single idea completely transformed IT. Cloud computing, disaster recovery, live migration, and even modern platforms like Kubernetes all build on the same foundation, turning hardware into software. The hypervisor is what makes the whole trick work. It's the software layer that divides physical CPU, RAM, and storage and hands each chunk to a guest VM. You'll see 2 types. Type 1, like VMware ESXi, or Microsoft Hyper-V, runs directly on the hardware without a host operating system underneath. It's built for top performance and runs most enterprise data centers. Type 2, like VirtualBox or VMware Workstation, runs as an application inside your existing Windows or Mac OS. Perfect for labbing and learning because you can experiment without wiping your main machine. Remember, Type 1 is bare metal, Type 2 is hosted. Quick recall. Which type of hypervisor runs directly on physical hardware without an underlying operating system? Here's where virtualization becomes powerful. Imagine buying one powerful server with 64 processor cores and hundreds of gigabytes of memory. Without virtualization, one application uses that entire machine. Most of its processing power sits idle. Now introduce virtual machines. Instead of running one operating system, you run many. One VM hosts Active Directory. Another runs SQL Server. A third hosts your company website. A fourth becomes a Linux development server. Each virtual machine behaves like an independent computer. If one crashes, the others continue running. They don't know they share the same hardware. That's why virtualization transformed enterprise IT. Instead of buying one server for every application, companies finally started using the hardware they already owned. Development teams test on 5 different operating systems using VMs on a single laptop. No extra hardware. IT Ops collapses a dozen old physical servers onto 2 modern hosts, slashing power and rack space. Security analysts spin up an isolated Windows VM to safely detonate a suspected malicious attachment without risking the corporate network. And in finance, a VM running Windows XP keeps a legacy accounting suite alive for audit purposes long after the physical PC that ran it was recycled. Every department has its own reason to love virtual machines. You may not realize it, but virtual machines are everywhere. When an organization runs Active Directory, there's a good chance it's running inside a virtual machine. Exchange server, virtual machine, SQL server, virtual machine, file servers, virtual machines. Even many cloud services begin life as virtual machines before higher-level cloud services are layered on top. If you work in systems administration, cloud engineering, cybersecurity, networking, or DevOps, understanding virtualization isn't optional. It's one of the foundational technologies modern IT is built on. That's why nearly every major cloud platform, including Microsoft Azure, Amazon Web Services, and Google Cloud, offers virtual machines as one of its core services. Learning virtualization today prepares you for almost every infrastructure job you'll encounter tomorrow. 4 reasons virtual machines are everywhere. 1. Hardware consolidation. A single Dell PowerEdge can host 3 or 4 server workloads that used to need their own boxes. 2. Isolation. If a test VM blue screens, your production web server keeps serving. 3. Snapshots. Right before a critical security patch, you save the state and can roll back in seconds if things break. And 4. Portability. That entire VM is just a file. Copy it to another host, or tuck it in a backup repository. These aren't just nice-to-haves. They're what turned VMs from a lab trick into the backbone of IT infrastructure. Here's a quick recall check. Name 2 business use cases for virtual machines from the departments we just covered. VMs emulate full hardware with a dedicated OS kernel. Containers share the host kernel. Think house versus apartment. A VM is a detached house with its own plumbing. A container is an apartment sharing the building's utilities. That means VMs offer stronger isolation, but slower boot times. Containers start in seconds and let you pack dozens on a single server. For running multiple distinct operating systems, pick VMs. For scaling microservices, containers win. A startup burned through its entire cloud budget in 2 months. 20 dev VMs left running over the weekend. $50,000 down the drain. The mistake? Nobody bothered to shut them off. In the cloud, a VM that isn't serving traffic is a meter running. So before you launch your first cloud VM, understand lifecycle management. Delocate when idle, schedule, start, stop, and set budget alerts. Back in part 2, you learned IaaS gives you OS-level control. Cloud VMs are exactly that. You rent a virtual server, manage the guest OS, and pay as you go. The big 3 providers, AWS EC2, Azure Virtual Machines, and Google Compute Engine, all let you spin up a tiny free tier instance or a massive memory-optimized beast. What you just practiced in VirtualBox, picking an OS, allocating RAM, attaching a disk, is the same skill set just at cloud scale. Let's set up a real VM. I'll assume you've already downloaded and installed VirtualBox from virtualbox.org. Once you open VirtualBox Manager, click the new button to start the wizard. Name it Ubuntu Test, choose Linux and Ubuntu 64-bit. Give it 2 gigs of RAM. Then create a virtual hard disk. Select VDI format, dynamically allocated, and set the size to 20 gigabytes. That's your empty VM ready for an operating system. Now we need an operating system. Download the Ubuntu Desktop ISO from ubuntu.com. In VirtualBox, attach it to the VM's optical drive under Storage Settings. Start the VM and it boots the installer. Pick your language, choose Normal Installation, and on the disk screen, select Erase Disk and install Ubuntu. Safe? It's only the virtual disk. Set time zone and user account, then wait a few minutes. You'll have a fully functional Ubuntu desktop running inside your main computer. Here's a quick muscle check. After you launch VirtualBox, what's the very first button you click to start creating a new VM? To launch a cloud VM from your terminal, use the AWS CLI. The command AWS EC2 run instances creates an EC2 instance. You supply an AMI ID for the operating system template. Choose an instance type, like T2 Micro for a small test. Just be sure to check the current AWS free tier for eligible sizes. Include a key pair for SSH access and a security group. Run that, and your cloud VM spins up in a couple of minutes. See the annotated parameters on screen. The simplest security blunder, exposing RDP or SSH to the entire internet. Setting a security group to allow source 0.0.0.0 on port 3389 means anyone on the planet can try to log in. Ransomware operators run automated scans for exactly that. Instead, lock the rule down to your specific IP, so only your trusted network can connect. A tiny config change saves your VM from being the next easy target. Lock in 4 essential VM habits. 1. Keep your guest operating system patched. An unpatched VM is an unlocked door. 2. Delocate or stop cloud VMs when not in use. A forgotten dev instance can cost hundreds each month. 3. Take a snapshot before applying any major update so you can roll back in seconds. 4. Never rely on a snapshot as your only backup. Export regular backups to external storage. Skip any of these, and you're gambling with downtime or data loss. Quick recall. Which common networking mistake leaves a new VM vulnerable to brute force attacks? Think back to the shield scene. What subnet address means the entire internet? The answer: leaving RDP or SSH open to 0.0.0.0/0 without any IP filtering. That's like leaving your front door wide open with a neon sign saying, "Hi, bots." No matter what OS you're on, there's a free hypervisor ready to go. On Windows, Hyper-V is built right into Pro and Enterprise, and VirtualBox works everywhere. Mac users, VMware. Fusion handles both Intel and Apple Silicon, and UTM is a slick, free option that's Apple Silicon native. On Linux, KVM paired with VirtManager gives you near bare metal performance, and VirtualBox is there too. Pick your platform, download, and you'll have a VM lab running in minutes. Now let's talk pro moves. A snapshot is a point-in-time save of a VM's disk and memory state. Think of it like a save point in a video game. Baseline to snapshot A to snapshot B. If snapshot B breaks something, you can revert to A instantly. Use this before any risky update. Nested virtualization means running a VM inside another VM. Perfect for building lab environments or training without extra hardware. And in the enterprise, live migration, vMotion, moves a running VM from one physical host to another with zero downtime. That's how critical services stay online even when a server needs maintenance. And regarding performance, we'll look at the numbers next, but the overhead is small and often negligible in practice. Is there a performance penalty? Yes, but it's surprisingly small and shrinking every generation. Modern hypervisors with hardware-assisted virtualization keep CPU and memory overhead in the low single digits, and even I/O overhead rarely exceeds a few percentage points for typical storage. For most workloads, web servers, databases, dev environments, the flexibility of VMs easily outweighs the tiny speed bump. The chart lays out conservative ballpark numbers. The gap is practically invisible in day-to-day use. Quick recall. What's a VM snapshot typically used for? Think about the diagram we just looked at. A point-in-time save with a revert arrow. The answer: saving a known good state so you can roll back in seconds. Perfect right before installing a patch or making a risky configuration change. Here's a concrete example. A local accounting firm runs one physical server, a Dell PowerEdge. Instead of buying 3 separate boxes, they spin up 3 VMs. A Windows Server VM running their ERP for accounting, a Linux VM hosting the company website, and a second Windows VM handling Active Directory and shared file storage. One machine, 3 isolated environments. No hardware sprawl, no extra cooling bills. That's the real power of virtualization for any business. We covered a lot. Let's lock it in. 1. A virtual machine is a software-defined computer that sits on a hypervisor, completely isolated from everything else on the host. 2. System VMs host full operating systems, while process VMs like the Java JVM run a single application layer. 3. You can spin up a VM right now with free tools like VirtualBox, and cloud VMs are just IaaS. Launch them with a console click or one CLI command. That checklist is everything we promised at the start. Where does this lead? In Part 5 of the IT Fundamentals Masterclass, we're breaking down containers. If VMs virtualize the hardware, containers virtualize the operating system. They're lighter, start in seconds, and are built for microservices. Think of it as the difference between a full server rack and a container ship. Same purpose, different scale. Get comfortable with VMs first, and containers will click immediately. Don't just watch, actually do this. Within the next 24 hours, download VirtualBox, grab an Ubuntu ISO, and spin up your first VM. Hit a snag, drop a comment with the OS you ran and what happened. This community is solid, and if you haven't already, bookmark the full IT Fundamentals Masterclass playlist. Each video stacks on the last, so skipping one leaves a gap you'll feel later. That's it for virtual machines. No fluff. No gatekeeping. Just real IT skills you can use tomorrow. Hit subscribe and turn on notifications so you don't miss containers. Explained next week. See you in part 5. Remember, careers aren't built by watching videos. They're built by applying what you learn. Pick one thing from today's lesson, build it, document it, and share it. That's how you get hired. Thanks for watching Hired in IT, where we're turning IT knowledge into career opportunities.